Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll take you through the fundamentals of Amazon Aurora, a powerful, fully managed relational database service designed for unparalleled performance and scalability in the cloud. We'll learn what makes Aurora unique, how it differs from traditional databases, and how to get started with deploying, configuring, and managing your own Aurora cluster. Let's get started. Amazon Aurora is not just another managed database. It's a cloud-native relational database engine that's been reimagined from the ground up to fully leverage the elasticity, resilience, and scalability of the cloud. It delivers the performance and availability you'd expect from high-end commercial databases like Oracle or SQL Server, but without the associated complexity, licensing headaches, or high cost. Built as part of the Amazon RDS ecosystem, Aurora gives you the best of both worlds. You get full compatibility with the tools, libraries, and drivers of MySQL and PostgreSQL, two of the most widely adopted open-source databases in the world, while benefiting from a massively improved underlying architecture. This compatibility makes it incredibly easy to lift and shift existing workloads, or even enhance legacy applications, with minimal changes to your application code or database schema. What truly sets Aurora apart is its modern, distributed architecture. Instead of relying on traditional monolithic storage systems, Aurora decouples compute from storage and uses a purpose-built, distributed, and log-structured storage engine. Your data is automatically replicated 6 ways across 3 physically separate availability zones in an AWS region, which means it's built for high availability and fault tolerance right out of the box, without you having to configure replication, failover, or backup schedules manually. The storage layer itself is fully managed and elastic. It grows automatically as your data grows, starting at just 10 gigabytes and scaling seamlessly up to 128 terabytes, so you never need to worry about pre-provisioning disk space or dealing with capacity constraints. That's a huge operational relief, especially for growing businesses or dynamic applications with unpredictable data patterns. Aurora is engineered for speed. It offers up to 5 times the throughput of standard MySQL and up to 3 times that of standard PostgreSQL, all while maintaining low latency even under heavy workloads. This makes it a go-to choice for mission-critical applications where performance and reliability are non-negotiable. Think e-commerce platforms, financial systems, SaaS backends, and enterprise workloads. Beyond performance and reliability, Aurora also offers powerful features to support modern development patterns and global scalability. You can scale reads horizontally with up to 15 low-latency read replicas. You can deploy globally distributed databases with Aurora Global Database for low-latency reads across continents. And for variable or unpredictable workloads, Aurora Serverless gives you the ability to scale compute capacity up or down automatically, helping you balance performance with cost efficiency. Unlike traditional databases that were designed for on-premises environments and later retrofitted for the cloud, Amazon Aurora was built for the cloud from day one. It features a highly distributed, self-healing storage architecture that's purpose-built to take full advantage of cloud infrastructure. Aurora automatically replicates your data across multiple availability zones within a region, which means that your database is resilient to infrastructure failures, zonal outages, and hardware issues, without requiring complex configuration or third-party tools. This architecture ensures high availability, fault tolerance, and rapid recovery from failures, making it an ideal choice for applications where downtime simply isn't an option. But it doesn't stop there. Aurora's storage is also fully elastic. It grows and shrinks as your data changes, scaling automatically from as little as 10 gigabytes all the way up to 128 terabytes. And it does this without any manual provisioning, which takes the burden of capacity planning completely off your plate. As part of the Amazon RDS family, Aurora offers the reliability and automation you expect from a managed service, with the added benefit of MySQL and PostgreSQL compatibility, making it incredibly easy for organizations to migrate their existing databases with minimal refactoring. Applications that rely on open-source relational databases can move to Aurora and instantly benefit from its advanced performance and operational capabilities without changing the way they interact with the database. Aurora isn't just about convenience. It's designed for serious performance. It can deliver up to 5 times the throughput of standard MySQL and up to 3 times that of standard PostgreSQL. It achieves this with a combination of optimized data processing, a high-speed SSD-based storage layer, and minimized I/O bottlenecks. Whether you're running online transaction processing, OLTP workloads, powering analytics dashboards, or handling real-time user interactions, Aurora can keep up with your most demanding scenarios. To support read-heavy applications and globally distributed user bases, Aurora includes several advanced features. You can spin up to 15 low-latency read replicas to scale reads horizontally. You can deploy a global database, enabling near instantaneous replication across AWS regions to support disaster recovery and globally available applications. And for unpredictable workloads or spiky traffic patterns, Aurora Serverless automatically adjusts compute capacity to match demand, so you only pay for what you use. Aurora also prioritizes security and operational simplicity. It supports automated backups, point-in-time recovery, and database cloning. Data is encrypted at rest and in transit using AWS Key Management Service, KMS. It integrates seamlessly with AWS Identity and Access Management, IAM, for fine-grained access control, and hooks into services like CloudWatch and CloudTrail for monitoring and auditing. Let's take a closer look at how an Amazon Aurora cluster is architected under the hood, starting with the compute and storage layers. At the heart of the compute layer is the writer instance. This is the primary node responsible for handling all write operations, inserts, updates, deletes, and schema changes. Every change made by the writer instance is immediately and synchronously committed to Aurora's highly durable storage layer, ensuring strong data consistency. Now here's where Aurora's architecture really starts to shine. The storage layer is completely decoupled from the compute layer and is designed to be shared and distributed. It's automatically striped across hundreds of underlying storage volumes and replicated 6 ways across 3 availability zones. This not only guarantees high durability and fault tolerance, but also eliminates the need for traditional storage provisioning or RAID configurations. For read scalability, Aurora allows you to add up to 15 read replica instances. These replicas can be deployed across multiple availability zones for better fault isolation and faster local reads. They asynchronously replicate data from the writer instance using Aurora's highly optimized replication protocol, which minimizes replication lag and ensures that your read replicas remain as close to real-time as possible. Applications can be configured to route read queries to these replicas, effectively distributing the read workload and improving performance, especially in high-throughput environments. Aurora even provides a reader endpoint, which acts as a load balancer to automatically distribute incoming read requests across available replicas. Under the surface, Aurora continuously monitors the health of both compute and storage components. The storage layer is self-healing. If a storage volume segment becomes degraded or fails, it's automatically replaced in the background, with no impact on performance or availability. This architecture, decoupled, distributed, and deeply integrated with AWS infrastructure, allows Aurora to deliver the kind of performance, availability, and resilience that modern cloud-native applications demand. So, why should you consider Amazon Aurora over traditional Amazon RDS? While both are fully managed database services within the AWS ecosystem, Aurora is designed to push the boundaries of performance, scalability, and reliability, making it a smart choice for modern, high-demand applications. Let's start with performance. Aurora offers up to 5 times the throughput of standard MySQL and up to 3 times the performance of standard PostgreSQL. It achieves this through a purpose-built architecture that minimizes disk I/O and optimizes data flow between the compute and storage layers. When it comes to scalability, Aurora leads again. While RDS requires manual intervention to adjust storage capacity, Aurora automatically scales storage from 10 GB to 128 TB per database cluster, eliminating the need for over-provisioning or costly downtime to resize. Aurora also takes replication to the next level. It supports up to 15 read replicas per cluster, 3 times more than RDS. These replicas can be distributed across multiple availability zones, allowing you to scale out read workloads and ensure high availability for global applications. In terms of availability and resilience, Aurora outperforms RDS with much faster failover times, typically under 30 seconds. RDS, in comparison, can take several minutes to failover, which might not meet the requirements of mission-critical systems. A key architectural difference is in how storage is handled. Aurora uses a distributed, fault-tolerant storage engine that's built specifically for cloud environments. This layer is decoupled from compute and replicated 6 ways across 3 availability zones. RDS, on the other hand, relies on EBS volumes, which limits both scalability and durability. Aurora also supports point-in-time recovery, PIR, and maintains continuous, incremental backups without impacting performance, so you can roll back your database to any second within your backup retention window. With storage auto-scaling, automated backups, patching, and maintenance, Aurora dramatically reduces operational overhead. There's no need for manual storage provisioning, and routine tasks are handled behind the scenes by AWS. And despite all these advanced capabilities, Aurora is designed with cost efficiency in mind. By minimizing administrative tasks, optimizing performance, and billing based on actual usage, Aurora helps teams get more value out of their infrastructure budget. One of the key strengths of Amazon Aurora lies in its flexible connection management, designed to optimize both performance and scalability across diverse workloads. At the center of this system is the cluster endpoint. This is your go-to connection for all read-write operations, and it always routes traffic to the primary writer instance in the Aurora cluster. It ensures that all changes to the data are directed to the authoritative source. But when it comes to scaling your read workloads, Aurora takes it a step further with the reader endpoint. This special endpoint intelligently distributes incoming read traffic across all available read replicas in the cluster. This not only boosts performance, but also helps applications seamlessly scale without needing to manually manage connections. For more granular control, Aurora provides instance endpoints. These let you connect directly to a specific instance, whether it's the writer or one of the replicas. This is especially useful for diagnostics, performance testing, or if you want to run specialized workloads on a particular node. Need even more customization? Enter custom endpoints. These allow you to create a connection that targets a specific subset of instances, say, a group of read replicas designated for analytics or reporting. This helps isolate heavy or long-running queries, protecting your primary workloads from interference. Aurora also handles failovers gracefully. If the primary writer goes down, the cluster endpoint automatically redirects traffic to the new writer instance after failover, keeping your application highly available without requiring any manual reconfiguration. Meanwhile, the reader endpoint takes care of load balancing, ensuring read traffic is evenly distributed across all replicas. This maximizes throughput and helps maintain consistent performance, even under high load. Aurora's connection management also integrates smoothly with AWS services like Lambda, Fargate, and RDS Proxy, making it a great fit for serverless or containerized applications that demand high concurrency and low latency. One of the standout features of Amazon Aurora is its storage layer, intelligently designed to grow with your workload, automatically and effortlessly. Unlike traditional databases that require manual provisioning and scaling, Aurora storage starts at just 10 gigabytes and automatically expands in 10 gigabyte increments as your data grows. It can scale all the way up to 128 terabytes per database cluster without any impact on performance or availability. Even better, Aurora doesn't just grow, it also shrinks. If data is deleted and no longer needed, the storage layer can automatically reduce its footprint, helping you keep costs under control. Behind the scenes, Aurora storage is built for resilience. Every piece of data is replicated 6 ways across 3 availability zones. This multi-AZ architecture ensures that your data is durable, fault-tolerant, and highly available, even in the face of hardware failures or network disruptions. It also features a self-healing mechanism. If Aurora detects data corruption on any of the replicated copies, it automatically repairs the issue by referencing healthy versions without any user intervention. This means your data remains reliable and your applications stay up and running. Performance is another key advantage. Aurora uses a distributed, log-based storage system that minimizes disk I/O, reduces write latency, and significantly boosts transaction speed. The result is faster response times for your workloads, even as they scale. What's more, storage scaling happens with zero downtime. You don't need to take your database offline, schedule maintenance windows, or manually reconfigure anything. Aurora adapts in real time, so your applications remain fully available and performant. On the cost side, Aurora follows a pay-as-you-go pricing model. You're only charged for the storage you actually use. No more over-provisioning just to handle occasional spikes in demand. The core of this performance is a distributed, log-based storage system that dramatically improves transaction speeds. By decoupling compute from storage and writing changes as logs, Aurora minimizes disk I/O and reduces the overhead traditionally associated with database writes. For analytical workloads, Aurora offers parallel query execution, which allows complex queries to be broken down and processed concurrently across multiple CPUs. This significantly boosts the performance of reporting and data-intensive operations. Aurora also includes in-memory query caching, which stores the results of frequent queries in memory. This can drastically reduce response times for repeated reads, making applications feel faster and more responsive. As demand fluctuates, Aurora adapts in real time. IOPS and throughput scale automatically based on workload intensity, ensuring that you maintain consistent performance without manual tuning or provisioning. Under the hood, Aurora's optimized write path is designed to minimize disk contention. This improves concurrency and allows the database to handle more simultaneous transactions without bottlenecks. To scale reads, Aurora supports multiple read replicas that can serve queries independently of the primary writer instance. This not only offloads traffic but also reduces latency for globally distributed applications. For observability, Aurora integrates with tools like Amazon RDS Performance Insights, which provides deep visibility into query performance and bottlenecks. You can drill down into query plans, resource usage, and latency contributors with just a few clicks. Aurora also connects seamlessly with Amazon CloudWatch, providing real-time metrics on database health, performance, and resource utilization, helping teams monitor, alert, and troubleshoot proactively. And for those designing modern, scalable systems, Aurora pairs well with architectural patterns like CQRS, Command Query Responsibility Segregation. By separating reads and writes into distinct models, Seek enables independent optimization of data retrieval and updates. Aurora's support for read replicas and scalable endpoints makes it an ideal fit for this approach, offering powerful flexibility and performance at scale. As modern applications become more dynamic and distributed, managing database connections efficiently becomes critical. This is where Amazon RDS Proxy comes into play, enhancing both performance and connection management for Aurora workloads. At its core, RDS Proxy acts as an intelligent connection pooler. Instead of creating and closing database connections for every user or function call, which can be time-consuming and resource-intensive, RDS Proxy maintains a pool of warm, ready-to-use connections. This dramatically reduces the overhead of connection churn and speeds up application response times. This connection pooling capability also makes Aurora far more scalable. RDS Proxy can handle thousands of concurrent connections, a game changer for applications like AWS Lambda or Fargate, where high concurrency and unpredictable traffic patterns are common. With reduced latency, applications no longer need to wait for new database connections to be established. Instead, they connect almost instantly through the proxy, which helps deliver a snappier, more consistent user experience. In the event of a database failover, say if the primary Aurora writer instance becomes unavailable, RDS Proxy automatically reroutes traffic to the new writer instance. This helps maintain continuity and significantly reduces the failover time for critical applications. From a security standpoint, RDS Proxy integrates seamlessly with AWS IAM Authentication and Secrets Manager. This allows secure and centralized management of database credentials, eliminating the need to embed credentials in code or configuration files. It also plays a role in cost optimization. By managing connections efficiently and reducing idle load on your Aurora instances, RDS Proxy helps you get more out of your existing infrastructure, especially important for applications with spiky or unpredictable traffic patterns. Best of all, RDS Proxy is fully compatible with serverless and containerized environments like Lambda and Fargate, making it a natural choice for modern architectures that demand elasticity and resilience. And just like Aurora, RDS Proxy is built with high availability in mind. It runs across multiple availability zones, ensuring that connection management is not a single point of failure, even in highly distributed systems. In this architecture, we're looking at how Amazon RDS Proxy plays a critical role in managing database connections efficiently, especially in high concurrency environments. Clients initiate requests that are first routed through an application load balancer. The load balancer distributes traffic to an auto-scaling group of EC2 instances, your application tier that dynamically scales based on demand, instead of having each EC2 instance manage its own database connections, which can quickly overwhelm the Aurora cluster. These instances connect to Amazon RDS Proxy. RDS Proxy sits between your application and the Aurora cluster, intelligently managing thousands of concurrent database connections. It maintains a pool of warm connections to the Aurora database, enabling efficient reuse and drastically reducing the overhead of frequently opening and closing connections. Behind the scenes, RDS Proxy connects to the Aurora primary writer instance for all write operations and seamlessly distributes read queries across two read replicas, improving throughput and read scalability. For secure credential management, IAM authentication is used to verify access, and AWS Secrets Manager stores the database credentials securely. This eliminates the need to hard-code sensitive information in your application and simplifies credential rotation. In the event of a failover, RDS Proxy detects the change and automatically redirects traffic to the new writer instance, ensuring high availability with minimal disruption. Imagine a database that grows and shrinks its compute capacity based entirely on your application's needs, without you having to touch a single setting. That's the power of Amazon Aurora Serverless. Aurora Serverless takes the operational burden out of scaling by automatically adjusting compute resources in real time. Whether your application experiences sudden spikes in traffic or sits idle for hours, Aurora seamlessly scales up or down, ensuring optimal performance without over-provisioning. There's no need for manual provisioning of database instances, making it a perfect fit for applications with unpredictable workloads, such as event-driven systems, development and testing environments, or services that experience periodic bursts of traffic. And when your application isn't in use, Aurora Serverless can pause itself to save costs, then resume automatically when new requests come in. This intelligent pause and resume functionality makes it extremely cost-effective for infrequent workloads. Aurora Serverless follows a pay-per-second billing model, so you only pay for the exact compute time your database uses. This dramatically reduces waste compared to traditional provisioned instances. To handle varying workloads more efficiently, it supports connection pooling, which helps absorb traffic bursts and minimizes the performance overhead associated with frequent connection creation and teardown. Unlike traditional architectures, Aurora Serverless can scale horizontally across multiple instances, adding more capacity on the fly as demand increases, without disrupting your application or requiring downtime. Best of all, you're not dealing with the complexity of instance sizing, scaling policies, or performance tuning. Aurora Serverless removes all that noise and simplifies database management, freeing your team to focus on building and innovating, not babysitting infrastructure. Whether you're building modern microservices, experimenting in dev test environments, or supporting variable workloads, Aurora Serverless delivers the perfect balance of performance, scalability, and cost efficiency on autopilot. When your users are spread across continents, delivering fast, consistent, and highly available data access becomes a serious challenge. That's where Amazon Aurora Global Database steps in. Purpose-built for globally distributed applications. Aurora Global Database enables cross-region replication, allowing you to create read replicas in multiple AWS regions. This dramatically reduces read latency for users around the world, who can now access data from the region closest to them. But it's not just about speed, it's also about resilience. In the event of a regional disruption or disaster, Aurora can promote a read replica in another region to become the new primary, often in less than 60 seconds. That's near instantaneous failover, ensuring your applications stay online when it matters most. To achieve this, Aurora uses dedicated infrastructure for replication, enabling near real-time data transfer between the primary and secondary regions, with latencies typically under 1 second. Each secondary region can independently scale up to 15 read replicas, allowing you to distribute read traffic across multiple geographies without overwhelming your primary database. This makes it ideal for global reporting, content delivery, and real-time dashboards. For PostgreSQL workloads, Aurora even supports multi-region writes through a feature called write forwarding. This allows applications in secondary regions to submit writes locally, which are then forwarded to the primary instance, significantly reducing perceived latency and improving responsiveness. Global applications often have to comply with regional data residency laws and privacy requirements. Aurora Global Database helps address these needs by keeping data within designated regions while still enabling global read access. And like most AWS services, Aurora Global Database operates on a pay-as-you-go model. You pay separately for the secondary regions and replication data transfer, giving you granular control over costs. It also integrates seamlessly with the broader AWS ecosystem. Whether you're streaming events with Kinesis, triggering functions with Lambda, storing data in S3, or monitoring performance through CloudWatch, Aurora Global Database supports true global scale applications without complexity. Let's take a closer look at the architecture of an Aurora Global Database deployed across two AWS regions. In the primary region, we have an Aurora cluster composed of a writer instance and two read replicas, each distributed across three separate availability zones. This setup ensures high availability, durability, and fault tolerance within the region. Beneath the compute layer lies Aurora's distributed storage engine, which is automatically replicated 6 ways across those three AZs. Importantly, all write operations happen in the primary region, and they are synchronously committed to this local storage layer to guarantee data consistency and durability. Now on the right, we have the secondary region. This region hosts 3 read replicas, also spread across 3 availability zones. These replicas receive data asynchronously from the primary region. This asynchronous cross-region replication is handled by a dedicated Aurora infrastructure designed to minimize latency, typically under a second, ensuring near real-time access to data globally. Notice that the storage layer in the secondary region mirrors the setup in the primary, but here it is read-only. Writes don't happen locally in the secondary region's storage layer. However, this brings us to a powerful feature: write forwarding. In the PostgreSQL-compatible edition of Aurora, if an application in the secondary region attempts to write data, the request doesn't fail or require rerouting. Instead, it is automatically forwarded to the primary writer instance in the primary region. This means applications in the secondary region can behave as if they're writing locally, even though those write operations are processed remotely. This improves the user experience by maintaining application responsiveness, while still preserving a single source of truth for all write activity. With this architecture, you get globally distributed reads, disaster recovery with fast regional failover, and the flexibility to forward writes across regions, making Aurora Global Database an ideal choice for mission-critical applications that span the globe. Amazon Aurora is not just powerful, it's also cost-efficient, thanks to a flexible, pay-as-you-go pricing model that scales with your actual usage. First, there's no need for upfront infrastructure investment. Aurora lets you pay only for the resources you consume, making it a smart choice for both startups and enterprises that want to avoid over-provisioning. Aurora's compute costs are tied to the size of your database instances, measured in virtual CPUs and memory, and are billed per second, with a minimum charge of just 5 minutes. This granular billing model helps reduce costs for short-lived or bursty workloads. Storage is fully elastic. Aurora auto-scales storage from as little as 10 gigabytes all the way up to 128 petabytes, and you pay only for what you use. Unlike traditional databases where you have to guess and provision ahead of time, Aurora removes the guesswork and the waste. Instead of paying for provisioned IOPS like in traditional RDS, Aurora uses a usage-based pricing model for I/O operations. You're billed based on actual read and write requests, making costs directly tied to application activity. If you're using Aurora Serverless version 2, pricing becomes even more efficient. Instead of fixed size instances, it scales up and down automatically, and you're billed in Aurora capacity units, AUs, per second. This model is perfect for unpredictable or event-driven workloads. Aurora also includes automated backups at no additional cost, up to the total size of your database. If you exceed that or use manual snapshots, those incur additional storage charges. Data transfer is straightforward. Inbound transfers are free, while outbound transfers, whether to the internet or other AWS regions, are billed according to standard AWS data transfer rates. And if you're leveraging Aurora Global Database, keep in mind that secondary regions come with additional costs for compute, storage, and replication, based on the volume of data replicated across regions. One of the key benefits of using Amazon Aurora is its robust and fully managed backup and recovery system, designed to protect your data with minimal effort and zero performance impact. Aurora performs automatic daily backups, retaining them for up to 35 days. These backups happen continuously in the background, without affecting your database performance or availability. In the event of accidental data deletion or corruption, you can use point-in-time recovery, PITR, to roll back your database to any specific second within your backup retention window, giving you fine-grained control to restore just before an incident occurred. You also have the option to take manual snapshots at any time, which can be retained for as long as you need, perfect for long-term archival, version backups, or compliance needs. All backups and snapshots are securely stored in Amazon S3, taking advantage of its high durability and availability. And for disaster recovery scenarios, you can replicate backups across AWS regions, ensuring your data is protected even if an entire region becomes unavailable. Aurora also supports snapshot export to Amazon S3, allowing you to extract data and run analytical workloads on it using tools like Amazon Athena or EMR, without impacting your live production database. When you need to recover, instant restoration from snapshots means your database can be brought back online quickly, minimizing downtime and getting your applications back up and running without delay. Monitoring Amazon Aurora is essential to ensure your database is performing efficiently, scaling properly, and operating with high availability. Aurora offers a rich suite of tools and integrations that make it easy to gain deep visibility into your workloads. To start, Aurora is tightly integrated with Amazon CloudWatch, providing real-time metrics on CPU, memory, disk I/O, database connections, and replica lag. With CloudWatch alarms, you can proactively detect and respond to performance issues before they impact your applications. For globally distributed workloads, keeping an eye on replica lag is critical. Aurora provides this metric out of the box, allowing you to ensure read replicas are up to date and performing well. For more granular insights, Performance Insights is a powerful built-in tool that visualizes database load and highlights the top resource-consuming SQL queries and wait events. This makes it easy to diagnose slowdowns and optimize query performance. For query-level diagnostics, Aurora enables slow query logging and general query logs. These logs help developers and DBAs trace performance issues back to specific queries and optimize accordingly. Aurora also supports enhanced monitoring, which delivers per-second metrics from the database instance's operating system. This gives you deeper insight into low-level resources like CPU steal time, disk queues, and memory usage, helpful for identifying bottlenecks outside the database engine. To stay informed of important events, you can leverage RDS event notifications with Amazon SNS. These alerts can notify you of failovers, instance restarts, storage scaling, or maintenance events, helping ensure that operations teams can take action swiftly. Additionally, Aurora integrates with AWS CloudTrail, allowing you to audit API activity across your Aurora environment. This is especially valuable for compliance and security monitoring. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.